All right, so in this example, we're going to look at a projectile being launched at a angle from the horizontal. So we're going to look at a velocity that's no longer pointed directly along the x or the y axis. We're going to be looking at a projectile that's launched into the middle of the the y and the x axis. So let's just label that. So here's our y, here's our x. So we can tell that this arrow is pointed in both the x and the y. And just as we did in forces, we're going to take this vector and we're going to split it into its x and y components. So we're going to take this part here and say this is the initial velocity in the x. And this here is our initial velocity in the y. Okay, so initial velocity x, initial velocity y. Well, if we look at this, we know it's the adjacent side to this angle. So we take the hypotenuse of 20 meters per second and we multiply it by the cosine of 60. Okay, and then we take the opposite side that we have here, the opposite side, multiply it by the hypotenuse, and opposite is always the sine of 60. Okay, so our x component is going to be the cosine of 60, if you look at your trig chart, is 1/2. So 20 times a half is just going to be 10 meters per second. We can do that one in our heads. This one, you'll need a calculator. The sine of 60 times 20, you're going to get a result of 17.3 meters per second. So, in other words, if we redraw our example here, we have a ball that's getting launched in both the x and y, but if we think about them separately, as we're supposed to do in 2D motion, because they act independent of one another, we can see that it has an initial x equal to 10 meters per second, and it has an initial y equal to 17.3 meters per second. So then we can have two separate one-dimensional problems that's going to be much easier to solve. So my first question is, how much time does it take to reach max height? Well, there's a couple important things we need to know. If we're talking about max height, we're definitely going to be using our y velocity because we're talking about going up and down. So let's write down our initial y, 17.3 meters per second. And let's put a positive sign on there because it's going to be in the positive direction. We also know that there is acceleration in the y dimension, and that acceleration is due to gravity. So the acceleration, we're going to be a little more specific here. We're going to say the acceleration that's just in the y is equal to 10 meters per second squared. But we know that that acceleration is pointed down, so we got to make sure we put a negative sign in that in front of that number. So now if we think about it's getting launched at 17.3 meters per second in the positive direction, and each second it's losing 10 meters per second squared. It's slowing down by 10 meters per second. We can very quickly see, without even doing any math, that if it's in the first second, it would lose this one here. It would only be going positive 7.3. And so really, the trick is here that to figure out how much time it takes, you just take your initial y and you move the decimal over. So the time of max height, because that's when we're reaching that time, equals 1.73 seconds. And if you want to see the math here, the change in velocity equals the acceleration times time. So change in velocity is final minus initial. At the top it has a 0, so that's our final, minus the initial was 17.3 equals negative 10 times t. Well, 0 minus 17.3, we don't even need that 0. divide by negative 10, divide by negative 10. You're always going to divide by negative 10, and that's why you get that 1.73 seconds back. So the time that it takes to get max height, that's going to be an easy calculation for all these problems. You're just moving the decimal over on that initial y velocity. How much time is it in the air total? So what's the total time? What is the total time in air? Well, we know that it follows a parabolic path when it goes up. So we said earlier this week that the time it takes to get to the max height is the same time it takes to fall back down to its original height. So the total time is just going to be the time to max height times 2. So our time total will equal 1.73 times 2, which is going to be 3.46 seconds. So that's how much time it is in the air in total. So we can see that we have that symmetry. We go up for 1.73, we come down in another 1.73 for a total of 3.46. Okay, my next question, I'm going to scoot this up a bit, is going to be, what is the max height? How high does it get? Well, again, we're talking about height, so we're going to be using our y-dimensional quantities. So let's just write them down again. We've got our initial velocity in the y equal to positive 17.3 meters per second. We know it's accelerating in the y at negative 10 meters per second squared. And now we know the last quantity we need is the time. We have to be really clear. What time are we going to use? Well, we're looking for the time that it hits the max height. So we're going to definitely use this 1.73. So let's say time max height equals 1.73 seconds. Okay, if we're looking for a displacement, meaning a height, a position, how far it gets up into the air, we're going to be using this equation here. Our change in y position is equal to just the initial velocity, we have to be specific and say in the y, times time, plus 1/2 the acceleration, but more specifically the acceleration in the y, times time squared. And we have all of these quantities written up here. So this just becomes plugging in all these values. So change in y equals 17.3 times 1.73 plus 1/2. Make sure you get that negative sign in there. If you don't put that negative sign in here, this whole term gets the opposite sign and it becomes incorrect. So be clear. 1.73. And I'll save the calculations. If we put this all through, we'll see that we get a max height, actually a pretty neat number here, of 15 meters. So it goes 15 meters up into the air before returning back down to its original position. Okay, so let's do our last question. Let's put this, how far does the ball travel in the x dimension? In other words, how far does it go across the ground? How far, if this parabola goes here, what is the distance from here to here? How far away from the person throwing it is it going to land? We just need to be clear about what values we're going to use here. Now we're talking about our x dimension. So we need to go back up to the top and make sure we have kind of set this one aside, but this 10 meters per second was our initial velocity in the x. So let's go ahead and put that one down here. Our initial velocity in the x equals positive 10 meters per second. Now if we think back to how the object is moving in the x dimension? Well, remember, there's no acceleration in the x dimension. The only acceleration is gravity, and that is in the y dimension. So the acceleration in the x equals 0, nothing. So what this becomes is a constant motion example. It's constant motion. So all we need to know, we're trying to figure out how far it goes, is just how long it's traveling for. So we know it's going for at 10 meters per second. If we know how long it's traveling for, we should be able to figure out how far it goes. Well, if we look at our 2 times that we found here, we're looking at how far in total it goes. So we're going to use this total time it was in the air to find this one out. And we see that the change in x position is just going to be the velocity times the time. So the change in x will equal 10 meters per second positive times 3.46 seconds. And we see that it travels a total of 34.6 meters. Great. So now we found just about all we can from this problem. We figured out how, first we split it into its 2 components. We split this angled velocity into its 2 components, 10 and 17.3. Then we use those 2 components to figure out the time it takes to get to the max height, the total time. Then we found out the max height using this equation here. Then we recognize that it's in the x dimension to figure out how far it goes. It's a constant motion problem. Constant motion in the x, only in the x. So we can use this basic equation and figure out that it goes 34.6 meters along the x-axis.